Welcome back. Let us go through the question first. Consider the decay of a free neutron at rest, so that the two-body decay of this type must necessarily give an electron of fixed energy, and therefore cannot account for the observed continuous energy distribution in the beta decay of a neutron or nucleus. There is a note here. The simple result of this exercise was one among the several arguments advanced by W. Pori to predict the existence of a third particle in the decay products of beta decay. This particle is known as the neutrino. We now know that it is a particle of intrinsic spin half but is neutral and either massless or having an extremely small mass, even compared to the mass of an electron, and which interacts very weakly with the matter. The correct decay process of the neutron is neutron to one proton plus electron. So the answer to the question is by Einstein mass energy relation, we can write energy equals delta m c square. Here delta m and c are constant, thus two-body decay is unable to explain or account for the continuous energy distribution in the beta decay of a neutron.